Okay class, Assalamualaikum and hi everyone. Alright, so in this video we are going to continue chemistry chapter 2 atomic structure, okay, which is we are going to do electron configuration. Okay, we will learn on how to write electron configuration in chapter 2.3. Alright, so let us proceed. So the learning outcomes of this topic is we are going to explain Aufbau Principle, Hund's Rule, Pauli Exclusion Principle. Okay. Then we are going to predict the electron configuration of atoms and monoatomic ions using SPDF notation and orbital diagram. Then we are going to justify the anomalous electronic configurations of chromium and copper only. Okay. Alright. So what is electron configuration ataupun susunan electron, konfigurasi electron. So electron configuration, it shows how electron are filled in the orbitals. Okay, dia menunjukkan bagaimana elektron diisi di dalam orbital. So this is because elektron, okay, kita boleh susun mengikut susunan dia. Okay, alright. So it also describe the arrangement of electrons in an atom. Okay, dia menerangkan susunan elektron di dalam atom. Dan the electron configuration of an atom and monoatomic ions can be represented by using two methods. Dia ada dua kaedah untuk kita explain ataupun menerangkan, okay, susunan electron configuration. So the first one kita menggunakan orbital diagram. Okay, dalam orbital diagram dia adalah box yang kita letakkan elektron, and then ataupun kita gunakan platform, then we write SPDF. Yang kedua adalah menggunakan XPDF notation. Okay, we use XPDF notation. Okay, so method 1, orbital diagram. Each orbital is represented by a box and each electron by an arrow. So meaning that orbital, box, electron, arrow. So the arrowhead indicates the direction of spin. Okay, dia menunjukkan arah spin, pusingan. So one half-headed arrow equal to 1 electron. So 2, okay, reversible arrow meaning that 2 electrons. So O8, okay, kalau O8 dalam box orbital diagram 1s, 2s, 2s2, 2p4. Jadi 4 tu kita letakkan di dalam, okay, kita letakkan di dalam box. Box ini adalah orbital diagram. Okay, box orbital kita. And then juga boleh ditulis menggunakan platform ataupun box. 1s, 2s, 2p. Okay, tapi I think it is preferable if you write using a box. Alright, yang kedua kita gunakan method SPDF. Kaedah SPDF notation. So writing the symbol for the occupied subshell and adding a subscript to superscript to indicate the number of electrons in that subshell. So 1s2, 2s2, 2p4. Okay, so n ini adalah dia punya principal quantum number. Tapi kalau dekat dalam orbital diagram, okay, dalam orbital diagram kita just tulis 1s, 2s, 2p. Okay, nombor 2, 2, 4 ini, okay, nombor yang ini 2, 2, 4, bilangan elektron kita lukis menggunakan half-headed arrow. Okay, alright. So angular momentum quantum number. Okay, so P itu adalah angular and then number of electron. Okay, di dalam subshell. So assigning electrons to orbital. Jadi bila kita nak letakkan elektron kepada orbital, okay, so kita akan menggunakan 3 rules. There are 3 rules apply for assigning electrons to the orbital of an atom at the ground state. Jadi dia ada 3 rule yang kita gunakan untuk assign elektron. Okay, so the first one ialah Aufbau Principle. Okay, kita menggunakan prinsip Aufbau. The second one we use Hund's Rule. Okay, and then the third one we use the Pauli Exclusion Principle. Okay, prinsip pengecualian Pauli. Jadi ada 3 rules yang kita akan gunakan. Okay, Aufbau, okay, Hund's dan juga Pauli Exclusion Principle. So kita pergi satu-satu. What is Aufbau Principle? Okay, let us discuss one by one. So electrons are arranged in its atomic orbitals in order of increasing energy. Okay, elektron disusun di dalam orbital atom, okay, dalam susunan peningkatan aras tenaga. Jadi, the orbital of lower energy are filled in first with the electrons and only then the orbitals of high energy are filled. So, maksudnya mula-mula kita isikan lower energy dahulu, okay, lepas tu baru kita masukkan kepada higher energy. Okay. Next, the order of filling of orbitals is, we start from 1s, 2s, 2p, 3s, then 3p, 4s, 3d, 4p, 5s. Okay, alright. So nanti ada yang tanya kenapa 3d dahulu? Okay, 4s dengan 4p ni 3d terletak di tengah-tengah. Okay, so nanti kita akan tengok di sini ya. Alright. Bukan 3d and then after that 4s. Okay, so this one dekat sini ya. Alright. This is because, okay, relative energy of atomic orbital, okay, tenaga dia, okay, dia akan increase mengikut, okay, this arrangement. So, lowest energy N1, N2, N3, N4. So, orbital 3D, okay, is higher than N is equal to 4S. Okay, so nampak di sini 3D lebih tinggi sedikit. Jadi, that's why 3D ni kita letakkan di antara 4S dengan 4P. Okay, in between. Alright. So, dalam hydrogen atom, kalau kita ada satu hydrogen, okay, satu atom, satu elektron. So, one electron, we just put 1S saja. Kita letak dekat dalam 1S sajalah. Okay, alright. Alright, so, tengok di sini. So, order of orbitals filling in multi-electron atom, okay. So, dia punya arrangement mengikut 1s, 2s, next, okay, 1s, 2s, next they go kepada 3, 2p, okay, 3p, 3s, and then 3s goes to 4p, 3s goes to 3p, 3p, 4s. After 4s, then we have 4d, okay, 4d, 4p. That's why arrangement dia start from 1s, 2s, 2p, 3s, 3p, 4s, okay, 3d, 3p, 4s, 3d, dan baru 4p, okay. So let's say kita ada vanadium 23. So the way we write is 1s2, 2s2, 2p6, 3s2, 3p6. 4s2, 3d3. Okay. So, kita letak 4s2 dahulu, baru 3d3. Okay. 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. Jadi, yang betul adalah yang di atas. Okay. Kita isi apa dahulu? 4s, then baru kita letak apa? 3d. Okay. Alright. So, kalau kita letak 3p, and then kita fullkan 3d5, this is wrong arrangement. Okay, arrangement dia bukan begini. Alright, yang kedua kita isi menggunakan Pauli Exclusion Principle. Okay, kalau tadi any increasing energy level, okay, Aufbau. Okay, next is Pauli. So the principle states that no two electron in an atom can have the same 4 quantum number. So maksudnya 4 quantum number kita iaitu N, L, M, S. Okay, jadi electron in a given orbital, okay, must have the same value of N, L, M, M. Jadi kalau salah satu orbital N, L, M boleh sama, tetapi different value untuk S. Only two values of S are possible, which is positive half dengan negative half. So, an atomic orbital can accommodate only 2 electrons. Thus, these 2 electrons must have opposite spin. Jadi kedua-dua ni dia mesti mempunyai spin yang berlawanan. Okay, alright. Consider helium. Helium ada 2 elektron. Jadi nombor quantum number dia adalah 100 positive half, 100 negative half. Thus helium atom has a following configuration. Okay, this one yang ini 100 positive half. This one is 100 negative half. Okay, alright. So different quantum number, okay, different quantum number because dia adalah different atom. Okay, right. So the following example are not allowed according to Pauli Exclusion Principle. Sebab apa? Yang ini dua-dua dia positive half. Okay, so that's why kita kena letak apa? Positive half satu, negative half satu. Okay, right. So the correct arrangement dia mesti satu atas, satu ke bawah. Okay, alright. So kalau macam ni boleh tak? Of course tak boleh. Sebab dia ada berapa? And 100 positive half, and 100 negative half, and 100 positive half. Okay, sampai 3 tak boleh. Okay, alright, so this is wrong. Alright, so the last one is Hund's rule. Hund's rule states that when electrons are added to the orbital equivalent energy, okay, each orbital are filled singly with electron of the same spin first before it is paired. So most stable arrangement of electrons in orbitals of subshells is the one with the greatest number of parallel spins. Okay, dia mesti kita isi dalam parallel spin dahulu baru kita pairing up. For example, kita ada carbon. So now carbon we have 6. So kalau 6 tak ada masalah because elektron dekat dalam 2p tu kita just letakkan 2 elektron yang sama spin, same spin. Okay. Kalau 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. So begini. Okay, kita letakkan opposite spin. So this is wrong. Kenapa? Because suppose this electron sepatutnya dia mesti letak di dalam parallel spin. Okay, alright. So dalam degenerate orbital ni maksudnya orbital yang sama. Okay, alright. So yang bawah tu is wrong. Jadi kita tak boleh lawan dia. Okay, so this is the arrangement. Example for arrangement for few elements such as nitrogen, oxygen, fluorine, and neon. Okay. Alright, so nitrogen 7. 1, 2. Okay. 1, 2, 3, 4, 5, 6, 7. Oxygen 1, 2, 3, 4, 5, 6, 7. And then this one is 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. For neon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Alright, fully filled. 2p6 is fully filled. Alright, so determine whether the following orbital diagrams are acceptable. So let us do some activity. Okay. Determine whether the following orbital diagrams are acceptable for an atom in a ground state. Explain the mistake and then draw the correct orbital diagram. Okay, so the first one, we have this orbital 2, 4, okay, 6. So this is correct. Okay, yang ini salah. Okay, because this one di dalam same spin. So salah. This is wrong. Alright, next. Okay, reason dia kerana dia di dalam spin yang mesti dalam spin yang berlawanan. Okay, this is wrong. Ini salah. Sebab apa salah? Because sepatutnya dia mesti mengikut Aufbau. Aufbau states that dia mesti isi lower energy first before higher energy. Jadi lowest ni 1s, dia tiada elektron. Okay, that's why this is wrong. Okay, dan yang itu tiba-tiba dia letak 2 di sini. Okay, so this one, what's wrong? Okay, so this is because this electron is pairing up. Okay, suppose dia kena letak apa dahulu? Same spin dahulu, parallel spin. Okay, so this is the correct writing. So this is wrong. Okay, so this is correct or wrong? Yes, this is wrong arrangement. Suppose, okay, electron dia mesti 1, 2, 1, 2. Fullkan dahulu 2s before dia pergi kepada 2p. Okay, sebab dia mesti mengikut Aufbau. Elektron mesti diisi dalam energi yang rendah dahulu before dia pergi kepada energi yang lebih tinggi. Okay, alright. Next, this one, correct or wrong? Yes, this is wrong. Okay, sepatutnya dia mesti isi dalam apa? Dalam same spin dahulu. Okay, alright. So yang dekat sini is wrong. Okay, as a conclusion, Aufbau Principle states that electrons are arranged in its atomic orbital Okay, in order of increasing energy. Okay, mesti isi mengikut 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. Hund's rule states that when electrons are placed in a set of orbitals with equal energies, degenerate orbitals, the electrons must occupy singly with parallel spins before they occupy the orbitals in pair. Now, Pauli Exclusion Principle states that no two electrons in an atom can have the same four quantum numbers, which is Nl, M dan juga S. So, anomalous, kita pergi sedikit untuk chromium and copper only. Okay, so this anomalous behavior is only occur for chromium and copper. Yang lain tiada. Okay, yang lain tak ada berlaku anomalous electron configuration. Chromium and copper have electron configuration which are inconsistent with the Aufbau Principle. Because according to the Aufbau, suppose we fill 4S full, baru kita pergi 3D. But the actual configuration, this one, okay, kalau ikut Aufbau, sepatutnya dia kena penuhkan 4S, baru dia pergi kepada, naik kepada 3D. Okay, yang kita expected. Tapi kalau actual, dia adalah 4S1 dengan 3D5. Which is, okay, kita akan explain later this one. And then kalau untuk copper pula, expected is 29. So this one is 2, 4, 10, 12, 18, 20, 29. Okay, tapi kalau ikut the actual electron configuration, okay, we found that dia mesti 4s1, 3d10. Okay, 4s1, 3d10. Bukan 4s2, 3d9. This occurs because 4s and 3d orbital are very close in energy. Okay. Alright, anomalous ini adalah kerana apa? Because 3d4, 4s2 is wrong. Okay, actual dia mesti 3d5, 4s1. Okay, one electron from 4s orbital is moved, okay, to 3d orbital in obtain more stable half filled 3d orbital. Tujuan dia mendapat half fill. Okay, kita tengok. Kalau D penuh dia 10, tapi kalau separuh 5. Jadi bila kita isi 5 di sini, dia lebih stable. Okay. Half fill 3D orbital is more stable than partially filled 3D orbital. Same case untuk copper. Copper predicted yang kita expect dia mesti 3D9, 4S2. Okay. 4S2, 3D9. Tetapi the actual configuration dia sebenarnya 3d10, 4s1. Okay. One electron from 4s is filled in 3d. Kita isi dekat dalam 3d. Kenapa kita isi dalam 3d? Because one electron daripada 4s orbital is moved kepada 3d orbital in obtain more stable completely filled 3d orbital. This is because completely 3d orbital is more stable than partially filled 3d orbital. Kalau dia 9, 9 electron, this one is 10 electron. Which one is more stable? Yes, of course, 3D, 10 more stable. Okay, sebab dia fully fill. Okay, ataupun completely fill 3D orbital. So this is the anomalous configuration. Only occur untuk siapa? For chromium 24 dengan copper 29. Yang lain-lain tidak ada. Tak ada anomalous electron configuration untuk elemen selain daripada chromium and copper. Yang lain semua mengikut aturan Aufbau, Pauli dan juga Hund's rule. Okay? Alright. Okay, so that's all for class in chapter 2.3. Okay, thank you class. Assalamualaikum and goodbye.